Hi friends, welcome back to our channel Physics Tutorial. Hope all of you are doing well. This is a part 7 video of our chapter Electric Charges and Fields. If you have not watched till part 6, please watch it before going ahead with part 7. Can we move to the video? In the last two videos, we were deriving the equations for electric field intensity on axial line and equatorial line of the electric dipole. Okay, now we can check is there any relation between these two equations. These are very important equations, and we studied that when we are applying a special condition, that is if 2A is very less than R, what was the equation for finding the electric field intensity? Yes, it was E. In the case of axial field, it is E equal to 1 by 4 pi epsilon 0 to P by R cube into P cap. Okay, so when we are writing it as a vector, and in the case of equatorial field, it is E is equal to minus P by 4 pi epsilon 0 R cube into P cap. So from these two equations, what we can understand? The electric field along the axial field is equal to twice of electric field along equatorial line, that is E axial will be equal to 2 into electric field along equatorial line. Okay, this is the relation connecting the axial field and equatorial field of a electric dipole. Clear? Here we are going to discuss another important aspect of electric dipole. Okay, that is dipole in a uniform external field. So we have to find the equation for finding torque on a dipole in a uniform electric field. Okay, now we can check the diagram. Here we have a uniform electric field of intensity E. Okay, now we have placed an electric dipole AB of dipole moment P and length 2A. So we can see that is plus Q charge and minus Q charge is there, and the length is 2A. Okay. Also we can see the angle theta, right? So that is the angle that is making the dipole with the electric field. Here also we can see the directions of the forces acting on the charges plus Q charge and minus Q charge. Just consider the charge plus Q. Okay, so how the force is acting here? We have the equation for finding electric field, right? E is equal to F by Q. Right, so from that, how we can find force? F will be equal to Q into E. Right, here plus Q is there. So what will be the force? So that will be plus Q into E. Right, so the direction is as shown in the diagram. And in the similar way, we can see the direction of the minus Q charge. That means the force acting on the minus Q charge. So what will happen here? Yes, that is in the opposite direction, right? F will be equal to minus QE, and that is in the opposite direction. Clear? So here what are the things that we have to mention? That is, consider an electric dipole AB of dipole moment P and length 2A. Okay, placed in a uniform electric field of intensity E. So these are the things that you have to note. Then let the dipole axis makes an angle theta with the electric field. So it is not that much important. And after that, what we have to mention here, the force on both the charges, right? So the force on the charge plus Q, that is at A, what will be the force? That we have already told, right? That is E is equal to F by Q. So F will be equal to Q into E. So the force on charge plus Q at A is equal to QE, that will be along the direction of electric field. Now we have to find the force on charge minus Q, that is at B. So what will be the force on minus Q? So F will be equal to QE itself, right? So here Q is equal to minus Q. So what will be the equation? F will be equal to minus QE. And what about the direction? Yes, here we can see that the direction is opposite to the direction of electric field. That is, both the charge, that is the forces due to plus Q and minus Q are equal and opposite. So here what is happening? These two equal and unlike parallel forces whose lines of action are separated, right? So what will happen here? It will constitute a couple. So the torque is acting on the dipole. So this torque will always try to align the dipole in the direction of electric field. Okay, now we have to find the torque. So that torque we have already discussed last year, right? Do you remember that? So that we can find the equation for torque. How we can find torque? Torque is always the product of force and perpendicular distance, right? Here force we have already calculated, that is QE, right? Then what about the perpendicular distance? So look into the diagram. Then here we can see the perpendicular distance, that is AC, right? Now we have to find AC. Okay, for that we can consider the triangle ABC, and here we have the angle theta. So how we can find AC from this? Yes, this is the opposite side, right? So we can find sine theta. So what we will get? Sine theta is equal to AC by AB, right? So what we will get? AC will be equal to AB sine theta, but we have AB, that is 2A, right? So can we substitute that? So what we will get? AC will be equal to AB into sine theta, that is equal to 2A sine theta, right? Now we can substitute the value of AC in equation number 1. So what we will get? We have tau is equal to QE into AC, right? So what we will get? That is equal to QE into 2A sine theta, right? But we have 2AQ is equal to P, right? That is the dipole moment. So what we will get? Torque will be equal to PE sine theta. So that we can write it in vector form as tau is equal to P cross E. So that is the equation for finding the torque on an electric dipole in a uniform electric field. Clear? Here this tau is equal to P cross E is the important equation that you have to remember. And suppose when theta is equal to 0 degree or 180 degree, what will happen? Yes, P cross E means P is sine theta, right? So sine 0, what is the value of sine 0? So that is 0. So what will be the value of torque? Torque will be also equal to 0, right? And another case is when theta equal to 90 degree. So what will come? Sine theta will be 1. So tau will be equal to P into E. So when we are getting maximum torque, that is when the dipole is perpendicular to the external field, or when theta equal to 90 degree, we will get maximum torque. And when the dipole is parallel to the external field, what will happen? The torque will be 0. That is when theta equal to 0, the torque will be minimum, and maximum value of torque is when theta equal to 90 degree. So these two special conditions also you have to remember. That is all about torque on a electric dipole. Now we can have a quick review of the torque on a dipole. Okay, so for finding that, first of all we are considering a uniform electric field, and we are keeping a dipole, that is plus q and minus q charges are there, which is separated by a distance 2a, and p is the dipole moment. Okay, so force we have to find first. So due to plus q charge we are getting QE as the force, and due to minus q charge it is minus QE, and these two equal and opposite charges will constitute a couple, and the torque is acting there. So for finding the torque, what we can do? Torque is equal to force into perpendicular distance, that is QE into AC is the perpendicular distance here. So AC we are getting by taking the triangle, that is sin theta equal to AC by AB. So AC will be equal to AB sin theta. Then when we are substituting, so torque will be equal to QE into 2A sin theta. Here 2AQ is equal to P. So we can write it as PE sin theta, or in vector form tau is equal to P cross E. And also we have discussed the two special cases, that is first one is when theta equal to 0 or 180, we will get minimum torque, that is tau will be equal to 0, and when theta equal to 90 degree we will get maximum torque, that is tau is equal to P into E. So that is all about torque on dipole in a uniform electric field. Hope it is clear to you. Now we can conclude the video. If you like the video, please like, share and subscribe. Thanks for watching.